Hi guys, welcome to the examples video for lesson 6.1a. In this video we're going to do two examples related to finding the values of trig ratios, so sine, cosine, and tangent for triangles. Okay, before we start, let's write down our helpful mnemonic device that helps us remember how the trig ratios are defined. So that's SOHCAHTOA. And I'm going to refer to this a lot because I do think it is helpful. The SO part is for sine, so sine is opposite over hypotenuse. The CA part is for cosine, cosine is adjacent over hypotenuse. And the TOA part is for tangent, tangent is opposite over adjacent. Some people even write SOHCAHTOA like this. So they can see the fractions right in there. It's up to you, write it however you feel is helpful. All right, so first example, I want to keep SOHCAHTOA on the screen. We're going to find the value of each trig ratio. So in order to do this, we need to label our triangle with the parts, the opposite, the adjacent, and the hypotenuse. I recommend starting with the hypotenuse because we know that it's across from the 90-degree angle always. It doesn't depend on theta. So shoot across from our 90-degree angle and we get our hypotenuse. So hypotenuse for this triangle is 5. And I'm going to even write hypotenuse right by it so I don't forget that that's the hypotenuse. Okay, the opposite and the adjacent depend on where theta is, so I'm going to mark theta. Our theta is here. To find the opposite, we want to shoot straight across the triangle from theta. And so 3 is our opposite for this triangle. Shoot straight across, and we get that 3 is the opposite. Okay, so we've got two sides, and there's only one side left. That's our 4. So that makes 4 the adjacent side. All right, so now that we have our triangle labeled, we can start finding the values of sine, cosine, and tangent for this angle. Sine, that's SO in SOHCAHTOA, right? Let's write that down here, SO. So sine is the opposite side over the hypotenuse. Okay, opposite side for this triangle is 3. So where I see opposite, I'm just going to put 3. And hypotenuse for this triangle is 5. So where I see hypotenuse, I'm just going to put 5. And that's all you need to do. That's all there is to this. Sine of theta for this triangle is 3 over 5. You can leave it as a fraction. We should expect them to be fractions. And that's it. That really is all there is to it. Okay. Cosine, that's the CA part of SOHCAHTOA. Okay, so CA stands for adjacent over hypotenuse. Okay, so adjacent side for this triangle is 4. So where I see adjacent, I'm going to put 4. And hypotenuse for this triangle, again, is 5. So where I see hypotenuse, I'm going to put 5. And that's it. Cosine of theta for this triangle is 4 over 5. All right, finally, tangent, that's TOA. So tangent is opposite, O for opposite, over A for adjacent. Okay, so to find the tangent, we need the opposite and the adjacent. So opposite for this triangle is 3. So I'm going to fill in 3 for opposite. And adjacent for this triangle is 4. So I'm going to fill in 4 for adjacent. And that's it. I've got my tangent. Tangent is 3 over 4. Okay, that's all there is to it. We're going to do one more like that. If you don't need another example, you can stop here. If you want to see another example, keep watching. So again, To start, let's identify the parts of the triangle. Let's start with the hypotenuse, straight across from the right angle. So 13 is our hypotenuse for this triangle, and I'm going to write it right next to it so I don't forget. All right, then I'm going to find my opposite. So theta is here. To find the opposite, I shoot straight across from theta. So 12 is my opposite for this triangle. And this theta. Shoot straight across. 12 is the opposite. That leaves only one remaining side to be our adjacent. So 5 is going to be the adjacent side. All right, we've got our triangle labeled. Let's start finding sine, cosine, and tangent. Let's do them out of order so we don't always think in the same order. So let's start with cosine. Cosine is ca, which stands for adjacent over hypotenuse. So to find the cosine, we need to know the adjacent side and we need to know the hypotenuse. Okay, adjacent side for theta is 5. So I'm going to fill in 5 for adjacent. And hypotenuse is 13. So I'm going to fill in 13 for hypotenuse. And I'm done. Cosine of theta is 5 over 13. All right, let's come down to tangent. Tangent is TOA, which stands for opposite over adjacent, right? Opposite over adjacent. So to find the tangent, I need to know the opposite side, which is 12. So let's fill in 12 for the opposite. And the adjacent side, which is 5. So let's fill in 5 for the adjacent. And that's it. Tangent of theta is 12 over 5. Okay, last one, sine. That's so, which stands for opposite over hypotenuse. Opposite over hypotenuse. So to find the sine, we need to know the opposite side, which is 12. And we need to know the hypotenuse, which is 13. So I fill those in and I get sine of theta is 12 over 13. And that's it. Okay, so now there's the examples together. Hopefully this helped you guys find the values of sine, cosine, and tangent for an angle. And thank you for watching.